Hi, everyone. Welcome to our CDCon session, Migrating from Package Release to Continuous Delivery, Challenges and Solution Patterns. My name is Balaji Siva, VP of Product at OpsMx. For people not familiar with the OpsMx, we provide intelligence continuous delivery solution based on open source Spinnaker. I've been part of Spinnaker community for the last 5 years, and I've seen a great success of Spinnaker and adoption. And happy to be here sharing what we have done with other customers. Joining me today with me is Gopinath Rebala, our CTO from OpsMx.
Thank you, Balaji. Welcome, everyone. I'm Rebala. I'm CTO of OpsMx, and we've been part of Spinnaker community for a few years now. And now we are a part of this continuous delivery foundation. We are excited to be part of it. And as Balaji said, we work on intelligent delivery solutions. And today we'll go through some of the projects that we have done and how we have implemented them.
Excellent, thank you. So here's the agenda. I will briefly touch upon our, the state of continuous delivery as we see it, and then I'll talk about some of the challenges with the package delivery process today. And then Gopi would go through a few use cases, real world customer scenarios, where we essentially solve some of these challenges. And I think that if you're still doing some of the monoliths and infrastructure updates as part of your software process, you definitely will benefit from it. So in terms of software delivery itself, I think the way we look at it is that the software development has been transformed. People have adopting microservices more and more, not completely, but at least definitely adopting, by majority of the people. And software process is faster now with the adoption of agile process, with the adoption of stateless services through either containers or or functions. There's been a lot of progress in that space. On the other side of the IT side or the infrastructure side, that's also been transformed. Now you can bring up hundreds of containers or the infrastructure in seconds, right? Compared to previously where you have to spend weeks to do that. But what's really still not solved essentially is the delivery. Taking that artifacts and putting it in the production servers. The need to do it at speed also has increased as businesses innovations are requiring them to make many updates quicker, from maybe hundreds of releases a year to like thousands or 10,000s of releases a year, multiple times a day, for example. And those things are making the existing process difficult. So what is challenging with the existing process? If you look at a typical CD pipeline, you have the check-ins, you do the testing, you do the staging, you do a production rollout, and then maybe roll back if needed. The current process, if you're not using something like a Spinnaker, for example, the orchestrating this whole pipeline, in terms of automating the workflow, making sure that you can deploy to multiple clouds, be able to quickly roll back, itself is a challenge. So that's first part of the problem. Let's assume you're actually adopting some of these technologies. The next set of problem is sort of not typically talked about in essentially a CD context, CD tool context, but it essentially is a process problem, right? So you have typically a gatekeeper that is actually approving from stage to stage, maybe from QA to staging to production, and that could take hours or and sometimes days. And also you have things that you need to do, like such as policy checks or security checks. Make sure that the version that you're deploying to production is actually the right version. Is it approved version, for example? Or you have other kinds of policy checks you need to make for security reasons or just compliance reasons, like SOX, for example. The other thing is, like, let's say you want to, everything from a security check passes, but what about the actual software itself in terms of the software validity, whether it has any performance issues or other kinds of issues. So you need to be able to verify the software. Typically you do it in a canary deployment and you try to figure out if the new version is good or not. And then you have to diagnose this. These could take hours as well. And finally, you have to have the audit. If in some cases you need to do an audit or any other kinds of activities, that could also take a lot of time. let's say you do find an issue like maybe a SolarWinds vulnerability in one of the software packages, how do you trace back everything that happened and make sure that no other software also actually has the same package, for example? So these are different challenges. This set of issues, both these orchestration and intelligence, exist for both microservices of modern applications as well as legacy or traditional applications. Today, our session is primarily focused on the traditional application side, but this can apply to both. So let's get into it. So if you look at different kinds of applications that you see in a typical enterprise, you obviously have the modern applications, which we talked about with microservices or functions, but then also you have other kinds of applications, a traditional application, which is essentially monoliths. And also you have things like, you want to do infrastructure as update. I mean, that's people are maintaining that as a package and they want to do infrastructure updates. Maybe you want to do a schema, data schema changes in databases or big data warehouses. So those things are also things people need to update every week, every day, basically, from in many enterprises. If you look at the chart on the left, bottom left, people are still, they although they're adopting microservices in droves, they're still not probably 50% of applications are still sort of monoliths. So this session is essentially trying to help you with doing these package releases of these non-containers, so to say, right, or non-modern apps. So monoliths, what is monolith? Is essentially, typically a package of multiple components that you test together and you try to release it together. And these things are as a service. They're not microservices. They're actually packages that you build in and you release it. This is the traditional application that we all know before. And infrastructure as code. So people are trying to do GitOps with infrastructure, meaning you have an ability to automatically update the state of the new applications, but they want to maintain the Terraform script, for example, as if it's an application. So you have versions of the Terraform scripts and you want to make sure that you test the versions of the Terraform scripts and then push it to production. The whole process today is done ad hoc. And so if you don't do in a proper way, it's causing a problems. So there will also be use cases where the applications and the infrastructure as code changes has to be tested together. So for example, you're making some changes to infrastructure, but then that may have some implication to the application that you're running on. So when you make these changes, you have to make sure that the application performance or security concerns are not changed with the infrastructure changes you're introducing. So this thing has to be tested together. And the last one is the database updates or schema updates. So you have obviously application changing, but also you may have to change your database schemas in the backend, or maybe the warehouse, database warehouse things, big data updates. So you need to do that also as a process instead of doing ad hoc. If you do it separately, you're going to have situations where you have some discrepancies in terms of these things happening out of sync. And so these things, what we call as package releases. How do you ensure these monoliths, this infrastructure, either with the application or without it, or the big data schema changes with the application, goes smoothly as a microservice application, right? Everybody knows how it works for a Kubernetes app, but what about these, right? And that's the goal of this session. So some of the high risk, some of the risk that these introduce. Essentially, there are some challenges, obviously, with these releases. One is the inability to test small changes in isolation. For example, you have multiple components. How do you test one component change in isolation? You need to basically package it all together and test it, and that'll be difficult. And also, if you need to roll back, you need to roll back a lot of set of changes because these are all a bunch of changes that's not coordinated in some sense. And you need to be able to make these changes, and it's awkward. It's challenging. It's obviously harder to troubleshoot because there are a lot of changes that are independent of each other, and components that are independent of each other, and it's difficult to bring that all troubleshoot them together. And lack of visibility, and this is a big problem in a large organization where auditing is important, as well as other things are traceability is important. If you don't have visibility into these changes going to production, it's going to slow down the whole process. So the goal of this session essentially is help you achieve sort of a continuous delivery even for these package releases. With that, I'm going to give it the slides over to Gopi.
Thank you, Balaji. I'll share my screen now. So we saw that Balaji set up the requirements for the continuous delivery and the challenges with monolith applications and the ones that have similar patterns. As we saw, the process in which the code is delivered or bits are delivered is very similar if you look at it 30,000 feet level. But once you start getting into the details on how we actually address these challenges, we start getting into the primary issues that cause the problems in delivering faster. Some of the common problems are these integration tests. Because these are monoliths, large number of components coming together, the tests themselves take a very long time. It's not uncommon to take for the integration tests for hours. Let's say they take 10 hours. And once we find a problem in 8th hour, you have to restart the test once that is fixed. But then finding the fix itself is an issue because there is so many different components are coming together. The experts in each of the systems are different. How do you triage and quickly recover from the problems? So these are some of the things that microservices solve much better. But we look at some of the challenges that we faced and how we address them. The other one that's getting more common is infrastructure changes themselves becoming part of the application. Now, with Amazon, AWS services, Azure, GCP providing so many different services with the databases, security, and messaging services, the applications taking advantage of them are now using so many of the services provided by cloud systems. And any changes that needs to be made to the application security, application performance, touch many of these things, and the infrastructure as a code is becoming a vehicle to do that. And troubleshooting this is similar, or delivering things faster is similar to the problems of the monoliths that we are seeing. So these are some of the things that we will look at today. To break it down, we will look at 3 specific use cases. One is a delivery system that is implemented at a large semiconductor manufacturer who has this big package system that they deliver for emulating the hardware systems. The other one is the SaaS vendor is completely opposite of the semiconductor manufacturer. So they have this infrastructure built on AWS using a bunch of services from AWS and then applications sitting on top, delivering these changes continuously to different tenants sitting on that SaaS platform. And the last one we will look at is how the database changes. Snowflake is a SaaS application by itself, but there are applications that are being developed on top of Snowflake. How do you manage in a compliant manner changes that are being delivered to the databases and changes to the applications? So the first one, let's look at the monolith application delivered at a semiconductor manufacturer. The challenge here is that there is a significantly advanced CI system. So hundreds of developers developing code, with multiple components, they're all coming together, but they still have this manual scripts that are deploying the components that are developed and then testing those. The tests themselves run 12 hours, a complete integration test before they can call it a release. And any changes like we discussed, problems that are found, they need to rerun the entire test suite. And the diagnosis itself is very complex. Multiple teams need to come together. There is no good collaboration platform for them to come together. And it could take days if some interesting problem is introduced. And that's not uncommon that interesting problems are introduced. So the way we approached it is there is a CI system well built that has parallel pipelines. And so the bottlenecks are in deploying the system with new components that are built on a continuous basis and improving the test process itself. instead of running all the tests one after another, break it down into parallel systems. You could run these tests in parallel. But before that, you also want to break it down as a smaller set of tests that allow you to test each build for its validity. And then integration tests you can run in parallel. Uh, and the third one that we have done is this intelligence part, where you implement a automated analysis that would associate some probability to the components that are there in the system, and then run an automated triage. So what does that mean? There are two things that we are doing here, right? One is build a pipeline with Spinnaker that allows us to do automated runs with a rollback. So previously it was ad hoc scripts that were deploying the system. There was no real way to roll back a component. And that we fixed by using containerized platform. Although it's not a microservice, you could still build a container. You could roll it back. And by using the automated analysis, you could identify the probability of these components. Now you can run, let's say there are 40 components in the system, identify 5 to 6 components that are the high probability for causing the problem. You run those 5 in parallel with the same test suite with a shorter term, and it automatically gives you the version of the component that could be causing the problem. And it improved the triage process tremendously. And the other thing that's benefit that came out is this collaboration between the teams. Now we are able to see the pipelines with Spinnaker that are running in parallel that give you what versions of the components are being deployed and tested and where the test is failing, and that could be shared between groups much more easily. And the logs are much more easily shared. It really improved their performance on this triage process, reduced the amount of time they need to triage, and over time, it will also reduce the amount of errors that you will see because these things could be automated. The complete opposite of that one is this cloud platform based SaaS application. It using multiple AWS services with Atlas, Hazelcast, Transit Gateway for securities, and then the application itself is running on ECS with the database with Elastic Cache and a bunch of services of AWS. Now, the challenge here is that for the application performance and security, the changes are not only happening for the ECS containers for the application functionality, but it's also dependent on the platform. So the platform itself is being deployed infrastructure as code using Terraform. The changes are not synchronized. Any issue that shows up, the triage process is again very involved and painful. It takes a tremendous amount of time from different groups because the configuration changes that are required by the application, if that is not properly tracked, it can take days to figure out what the issue is and clean up. As you know, the Terraform structure also changed between 10 to 12, 12 to 14, and the stage management with the Terraform itself needs to be properly understood. The lifecycle management of that needs to be managed. So here we looked into where the real bottlenecks are. The changes need to be tracked vertically. The changes that are made to the infrastructure as a code, the Terraform needs to be matched with the changes that are happening at the application level with containers, and together they need to be tested. So we built these pipelines with Spinnaker. As the change happens in the Git, we actually run parallel pipelines to verify the application functionality on the new infrastructure that is built, upgraded infrastructure, and with the new application code on top of it. Let's call them tenants. And only and these things are successful, we would allow them to go into the main branch in Git. And then any given time, the main branch is ready to be released. The lifecycle management happens through the Spinnaker pipelines. So this tremendously improved our ability to reduce the incidents. Previously, they used to have 2 to 3 incidents a week. Now it's almost close to 0, primarily because we catch them before they get applied into the main, and main is always in the ready state. And as we test it before we merge into the main, because we find the problems, they're immediately addressed. because these changes are small and easily caught. So this again, because the ability of Spinnaker to provide these pipeline views and the testing, there is an improved collaboration between the groups, and the overall process is tremendously improved by addressing a bottleneck one at a time. And the last one is this a Fortune 50 technology vendor. As you know, the changes that are being deployed, Snowflake is a analytic data warehouse platform. If you don't know, it allows data aggregation, data lake, and then build applications on top for data science workloads, or even simple analytics reporting kind of applications. Here, the goal is that the changes that are being made to the Snowflake is ad hoc scripts. And there is no process, the ability to control this Git process moving from one environment to the another. And these are also custom scripts that are not auditable properly. And so there's a compliance risk that was involved in making these kind of changes. So the solution was very clear in this particular case, is with provide the ability for pipelines to provide this approval process and promotion process. Essentially, you have these scripts that may be updating the Snowflake database schema that will be used by the application. So have the pipelines that work in conjunction with the changes that happen to the Snowflake database and the application that is being delivered, and construct these pipelines in Spinnaker, build in the approval process. So you have these custom stages that we build in that allow for the Sarbanes-Oxley kind of approval. And because these pipelines are visible and auditable, you have the compliance requirements that come in. And the PR merge process that move from one environment to the another for the scripts is also implemented as part of this process. And at the end, you could also do a rollback of the schema with the pipeline. So this allowed us to provide the ability to do a visible, compliant pipelines that allowed for their governance policies. So we went through some of these use cases here. As a core of it, as you can see, the challenges do exist, but by using Spinnaker and ability to construct these pipelines, identifying the bottlenecks and addressing them with the parallel pipelines, having an intelligence built in a little bit in terms of automated triage, we were able to improve the process tremendously. Automation is the key, but with that, there's some intelligence that needs to be built in, and use tools like Spinnaker that provide the ability to orchestrate complex workflows is the key to getting to the solution faster. The obvious benefit, again, is the collaboration with visibility across multiple groups. We're also looking at, in this, the additional intelligence with logs being generated from large number of services. As an OpsMx, we focus on intelligence delivery. You could identify all the services that you use with your application and allow it to do automated analysis of logs being generated by all the services of AWS, for example, and give you as analysis of your intelligence deployment delivery. That's all I have today. Balaji, do you have any thoughts before we go into Q&A?
Yeah, no, absolutely. Thank you for walking through those sort of three use cases. Just to summarize, I think we leveraged Spinnaker and helped customers with the adoption of many of these use cases. And there are also some enterprise features that we added to enable that to happen. And also, you look at some of the use cases. In order for it to be a fully continuous delivery process, you need to have these intelligence problem we talked about earlier, ability to automate approvals, ability to audit, ability to verification, ability to traceability. All of those things are built in. And that's what makes it a very robust solution, so that you can actually feel like you're not slowed down with these other applications, non-microservice applications. And our customers are able to kind of take both of the both microservices as well as the traditional applications and do a good job of it. If you have any questions, you have our contacts here.